Greetings, welcome to my channel. Thanks for stopping by. This video is about why I'm making some videos on programming and just an overview of how I see coding and programming working out in the year 2025. And to be perfectly honest, one of the reasons I decided to make some of these videos is that programming is now more and more visible to people of all backgrounds. And there's a lot more discussion about programming than there ever has been. And of course, there's probably not a more difficult time to be entering the field as a programmer as it is in this year. There's tons of reasons for this. One is that there has been a lot of layoffs and uncertainty about how one can make a career out of being a programmer. The other is, of course, the explosion of AI tools and the hype and the questions around those tools and how they affect programming. A bit about my background. I have a doctorate in computer science. I am not currently a programmer for reasons I won't go into in this video, but I do have also a lot of experience working in the corporate environment. I have done so off and on for 10 plus years in between me going to school. And so I do have some insight into how people actually have to deal with programming in the real world and the challenges that do come into that. And to be perfectly blunt, it's much more difficult than ever to actually see a path to how you can establish yourself as a career programmer, much more as what people call the senior developer, which is increasingly this vaunted title of someone who really seems to know what they're doing and has some expertise and is able to establish themselves in companies and move back and forth easily between jobs as they see fit. So what I'll say here is first basically some difficult types of things to discuss, but basically I'd say that junior developers are probably the least prepared by education and training than they've ever been. And there's a couple of reasons for that. One is that there is a lot more to learn. But two, that there's a lot more pressure from industry to make people into coders much more rapidly and to bring a lot more people into the field. Now, that's a good thing, but that also puts pressure on educational environments to reduce the requirements and the amount of information you have to learn in order to, say, get a degree in computer programming. Now, no one needs to have a bachelor's degree to be a good programmer. There's plenty of programmers out there that haven't. However, those that are successful do have really strong motivation to learn and are self-taught. And a lot of them have a lot of struggles on the way by not having access to education at the college level and people that have expertise in certain types of fields so that they can understand certain types of things better. The way this manifests in my mind is that actually there are programmers that just are less qualified and less knowledgeable than they had to be in the past. To give you an example, when I started out as a programmer, it was very hard for me to get into a program. And the reason being is that the resources that we used were extremely expensive. I started school in '92, and this is before Linux came out. And so we were using workstations in expensive computer laboratories. These workstations were literally tens of thousands of dollars. And the department that I was in wanted to ensure that the people that were using these resources were very motivated and very capable. And not only that, but they made sure that we were programming a lot and doing as much as we could in the lab and learning as much as we could about the field. Fast forward to nowadays, that is completely unnecessary. Anybody with a $500 laptop has more than enough resources to develop any kind of programming that you would need, apart from maybe some types of supercomputing or AA programming. But even the cloud makes some of those resources available. But there is no reason for colleges to make sure that students are really capable or highly motivated, because they do not have to provide the same level of resources. And that's actually overall a good thing, potentially. There's no reason to keep things highly strict when things are indeed much cheaper. And not only that, but the field has exploded, so there is demand for more types of programmers than, of course, when I started. That being said, what has actually happened is that a lot of people can get a 4-year degree and not even have to be exposed to the ideas that somebody who started when I was programming back in the 90s was required to learn. A good example of that is that I had to take a class on operating systems programming, compilers, databases, programming languages, theoretical computer science, as well as algorithms and data structures, all these types of things, just to get a degree. Most of these are now optional, and there's many other types of paths that you can do to get a degree. Again, that's just a matter of things maturing and that there's more types of stuff going on. For example, I never had to learn about web programming because web programming didn't exist. When I studied about networking, it was really about low-level networking concepts, not about higher-level networking or distributed programming. Certainly, I didn't learn very much about parallel programming. When I learned about threads, it was from an operating system perspective, of that very low-level concept versus how I would actually program a multi-threaded program or a distributed program. So things do change. And I don't want to come off as someone who's saying, well, back in my day, even though it is very hard not to do back in my day when I've been programming for as long as I've have. But one of the things that does seem to happen is that not having that background makes it really difficult to see how one can move from this junior developer to this more experienced person without falling into certain traps along the way, getting burnt out, or in the worst case being what some people call an expert beginner, in which where you've learned one or two skills and find yourself that you're unable to move past those when those skills may not be as in demand or as necessary or has moved on. I know plenty of programmers that have developed some skills, let's say in front-end web programming with certain frameworks, that when new frameworks came along, it was very frustrating for them to try to move on. And some of them actually didn't. They actually found themselves stuck in jobs that they really didn't like because they didn't see a way to move into newer types of positions or different types of programming. The other interesting thing is that if you look on social media and the types of programming that is out there, it provides a narrow type of lens into the vast amount of opportunities there are for programmers. It's easy to think that the only real goal will be to become a full stack developer at a very large and well-respected company like Facebook, Amazon, Apple, Netflix, Google, so on and so forth. Whereas one could have a very satisfying and career doing embedded development, for example, in C, and working in the automotive industry or other types of industries. There's plenty of people that have done very well doing programming in healthcare. I personally have done a lot of C# programming from various types of companies and have made that a pretty good part of my career, and I really enjoyed that, and it allowed me to work in certain environments that I think other people don't even know exist. Certainly, these are not the most exciting or sexy types of tech jobs, but they definitely do pay fairly well, and they tend to be sometimes have more stable work environments. But that still doesn't protect developers from this notion of burnout and being replaced with AI. And certainly there is a group of developers who skill sets are so compact that AI must seem really threatening, because it does the level of copying and pasting and trying to just throw things together to see if it works. It seems to do what they can do much more effortlessly and much more quickly. And they don't see the very real shortcomings of AI coding and how just typing in prompts constantly to come out with code does not necessarily lead you to a solution, nor does it allow you to work in a large distributed code base that already exists. Or frankly, the vast majority of jobs it can be somewhat of a help, but it doesn't really provide you the communication, teamwork, and other types of soft skills that you need to become a more successful programmer. So one of my focuses on making videos that I am about the Racket programming languages and programming is one of, I think, the big gaps that junior developers face now is that they do not actually have a fundamental understanding of what a programming language is. They basically learn a language, maybe two, learn how to do some things in that, and their knowledge stops there. And what that becomes difficult is when they are presented potential opportunities to move, but it requires them to, like, say, learn a new language or use a different type of language in libraries in a different type of way. They really can't move past that because they don't have the fundamentals on how to learn those new concepts and adapt them when they're working. So one of the ways I think that's very important to do that is that by breaking down the fundamentals and by examining programming in a very more abstract and, to be perfectly blunt, theoretical way, so that you can understand the fundamental building blocks. And all of a sudden, with these fundamental building blocks, each programming language becomes a variation on theme, and you can become much more able to move from one language to another. And certainly that is a thing where when I started programming, that was just a given, that you were going to be programming in multiple languages and you had to learn things fairly quickly. For example, when I was on a contract, they had the opportunity for someone that needed to do some Python development, and I volunteered to do that, even though I had not really done any programming in Python versus some just cursory explorations. And the reason being is that I knew that the language was not going to be a problem for me. I could quickly adapt, learn the syntax, download the PyCharm IDE to help me out with the autocomplete, and quickly move on to the real problem, which was understanding what they wanted the Python program to do. And sure enough, that was the case. It was very much a fairly simple Python project. I was able to work with the people there, get it done on time, and I was actually able to leave that contract a bit early because I was completed it ahead of schedule, even though I had never, as I said, done a Python program in my life. And the reason was that Python is just another type of programming. It was slightly, I knew all the differences about its type system and how it worked, and it was interactive and not. And not only that, but I was able to lean on tools that would help me do the things that are harder in other types of tools. I've never shied away from using things like IDEs. People now use language servers for the type of stuff, but never been one to have been stuck where it's like, well, if I can't write it up in Emacs and C tags, then I'm not going to do anything like that. I was like more than happy to have tools to help me do all the small bits that I didn't need to go through, like having to constantly refer back to a reference manual to figure out what call does what. So in the end, I also want to say I'm very sympathetic to the issues that developers are facing right now. It is incredibly frustrating. It seems that a lot of companies are really bent on just making it impossible to be hired. And the question mark is, how do they think that the new advances that senior developers and more experienced people are going to make? They seem to have forgotten where these people come from, that everybody was at this level or more was once a junior that really didn't know what was going on. So I hope you stick around for my series on the Racket programming language. I hope you're going to find it interesting. And thanks for watching. See you in the next video.